Hello and welcome back. I'm going to be solving a problem from refraction through prism. The question said a 60-degree prism is made of glass of refractive index 1.5. We are to calculate the angle of minimum deviation, the angle of refraction of light passing through the prism at minimum deviation, and then the angle of incidence at minimum deviation. Okay, so let's start. The first one say we should calculate the angle of minimum deviation. So to calculate the angle of minimum deviation, we use this formula. Refractive index is equals to sine open bracket the angle of minimum deviation plus the refracting angle divided by 2 divided by again sine the refractive angle divided by 2. Now this refractive angle is the angle of the prism, and since 60 degrees is given, that means it's a triangular prism and it is equilateral. So that A is 60 degrees, and then this dm is the angle of minimum deviation we are looking for, while this mu is the refractive index and it is given as 1.5. So let's substitute the values into this. So this is 1.5 sine open bracket dm plus A is 60 all over 2, then divided by sine 60 over 2 again. Alright, so let's deal with the denominator. Here we can just leave it as sine the m plus 60 over 2. Then the denominator now will be 60 divided by 2 will give you 30, right? So what is sine 30? Sine 30 is 0.5. So we have 1.5 is equals to sine open bracket the m plus 60 all over 2 divided by 0.5. So if we cross multiply now, this 0.5 will come and multiply 1.5, right? So we can have sine dm plus 60 all over 2 and it's equals to 1.5 times 0.5. This is going to give you 1.5 times 0.5 will give you 0.75. Okay, so since we are looking for the m, we can take the arc sign of, we'll divide both sides by sine so that we'll have the arc sign of this value. So we have dm plus 60 all over 2 is equals to arc sign of 0.75, right? So the m plus 60 over 2 is equals to arc sign of that value will give you what? So let's see, arc sign of 0.75 will give you 48.59. so dm plus 60, if we cross multiply, these 2 will go there, so it will be 48.59 times 2. So multiply that by 2, it will give us 97.18. So we are looking for dm, so the m will be equals to 97.18 minus 60. So let's subtract 60 from it. So we're going to be having 37.18 degrees. So the angle of minimum deviation is 37.18 degrees. So the second option said we should calculate the angle of refraction of light passing through the prism at minimum deviation. So at minimum deviation, we should know that the light inside the prism is symmetrically refracted and the refraction angle which is represented by letter R, is equals to the angle of the prism divided by 2. So this is I will just be as easy as 60 divided by 2, which gives you 30 degrees. We go to I say we should calculate the angle of incidence at minimum deviation. So at this minimum deviation that we have this value and this refractive angle, we should find the angle of incidence. So we all know that refractive index is equals to sine I all over sine R, right? So since we are looking for sine I, we can make sine I the subject of the formula. So sine I will be equals to refractive index times sine R, right? So I now will then be equals to sine inverse of refractive index times sine R, right? So we'll be having sine inverse of the refractive index that we already have. We already know it to be 1.5 times sine R. R is 30. So angle of incidence will be sine inverse of sine 30 is 0.5, so times y will still give us 0.75, right? Remember that value we got here. All right, so sine inverse of 0.75. So let's take sine inverse of 0.75. We're going to be getting 48.59. So we have 48.59, which will be approximately 48.6 degrees. So the angle of incidence is 48.6 degrees. That brings us to the end of this question. Thank you for following from start to finish. I wish you happy learning. Bye.